Hey, how y'all doing tonight? We are going to work on the back side of our fossil notes from class today, forming igneous rock. If you'll read along with me at the top, it says igneous rock is one of the three major types of rocks. It is formed by the hardening of molten rock, magma. Magma does not always reach the Earth's surface as lava erupts from a volcano. It often forms other igneous rock structures underground. And so we're going to use this page here to identify some of those igneous rock intrusions. First of all, we want to have the definition of what an igneous rock intrusion is. So we've got down here intrusive igneous rock formations. So these are often referred to as igneous rock intrusions. Now these occur when magma squeezes into existing rock layers. Intrusions are always younger than the rock layers they intrude. I'll give you a moment to get that written down. Now on the picture here we have the intrusions with a line, and we are going to be labeling them by their name. Intrusions are always named for their size and their shape and how they work with the rock layers that they're moving into. So the first one and the largest is called a batholith. So it is a large dome shape structure for magma when it cools. And we've talked about this when we were doing igneous rocks, and Stone Mountain is a batholith. If you can imagine this picture here with just that large dome and all of the volcanic material and rocks above it being eroded away and just left with the dome sitting above the surface. Now our next intrusion is called a laccolith, and it also is a dome, but it's a bit smaller, and it will squeeze into rock layers, between rock layers. So you can see in the picture here, it actually has pushed up a layer of rock, creating what looks like a hill in this picture. Okay, the next one is on the other side of the paper, and hopefully you can read this. I know it's a little bit difficult to read with all the dark of the picture, but this is a sill, S-I-L-L, and it is horizontal between rock layers. So it is a smaller amount. It can be kind of long and thinner, and the magma will actually move in between rock layers that are already there, and then it hardens and forms a sill. The last one here that we're going to look at is the dike. And if you can look at my arrow and notice that the line comes down here, and this is the dike right here. And you'll notice it's kind of like this area that we want, that a volcanic eruption might occur from, but it's still here and it never reached the surface. And so when it's a vertical, you can see it's up and down. When it's vertical, I lost my arrow, it's up and down, it is called a dike. So that is an igneous intrusion where magma has squeezed up through the rock layers and then solidified. And the last thing I want to mention is up over here. It's already come up, and you'll notice that this is a picture. Oops, sorry about that. This is a picture of an active volcano. But what we want to do here is imagine that this volcano has stopped erupting, And so we aren't going to have any lava up here erupting because intrusions do not form from lava flows. They only form when the magma below the surface cools and solidifies. And we'll be talking more about this as we get into our conversation on how we date and age rock layers and fossils. And what you really need to remember from this form here is that intrusions are always younger than the rock layers they intrude. You think about that, it only makes sense. You can't intrude something unless it's there. If it's already there, then it's going to be older. Now, how can you make a fossil? Well, come to class tomorrow and you'll find out.